Добрий день, шановні. My Ukrainian is really poor, so I'm going to use English, if you don't mind. Yeah, I'm really scared because there are so many of you here. And to optimize it a little bit, I created a Telegram group for this specific keynote, for this presentation. You can join it right now. It will exist for just 1 hour. And in this group, you will be able to talk to each other and ask questions to me. I do it sometimes at conferences. I'm not sure how it's going to work on a large audience, but we can try. So that's the name of the group. Join in. You will get all the information about this presentation. I'll share slides later and all that. And if you want to address the question to me specifically, then please start it with my name, because otherwise I may miss you. There will be many messages posted there. Let's start with, actually the talk is going to be quite provocative and it may trigger some of you to disagree with me. I'm expecting that, and that's why let me start with the question. How many actually QA engineers in this room? Can you raise your hands? There you go. So it is going to trigger, because I will try to prove you that you actually are not QA engineers. QA means quality assurance. So let's start with the presentation of some instruments and tools which you, of course, as QA people, QA experts, you actually use. Like, for example, this one, you know what it is, of course, you use it every day. It's affinity diagram. Or, for example, this one, which, of course, you also use every day in your work, which is a process decision program chart when you do QA work. Or, for example, this one, which is interrelationship digraph. Of course, you know what it is. And this one, this prioritization matrix, which you, of course, use again as QA engineers. And the matrix diagrams, you, of course, use them when you do the QA work. You know what it is. You can't work without them, right? And the final one, that's this one. You know what these graphs are. You also use them every day when you do the QA work, right? How many people actually know what it is? Okay, that's Six Sigma. Well, QA people know what that is. So you're probably confused, all right? Because none of these tools you actually use, or maybe some of you sometimes. And that's my point. That's the whole point of this talk, is that actually you're not doing the QA, you're doing something else. And let me show you something which software testers use in their everyday work. How about this? You know what it is, right? You use that. Some of you may know what this is, right? That's Selenium. You most probably use that tool. Some of you may actually use IntelliJ IDEA, for example. If you test the Java code, then sometimes you may need to open the Java code and read the Java code. And some of you may use this tool, which is like Apache JMeter, to do load testing and some similar tools. So the point is that QA is not testing, actually. QA is QA and testing is testing. There are two different disciplines in software development. And many of us are getting confused by this QA title. So we think that because we're testing, that means that we are doing QA. We are actually helping the quality of the project. We're helping the project to be of a better quality. But we are not doing QA. QA is something different. And now I will explain you what the difference is between the QA and testing. And we will see whether you are actually testers or QA people. And I'm not saying it in a bad way. I'm not saying that testers are, I'm not trying to diminish your title of your job, like I'm saying that testers are like, you know, second-class citizens and QA people. No, it's not that way. It's just different categories, just different types of work we do. And let me try to clear it up for you. I created this diagram and I'll show you for you. So let's say I'm a project manager, a PM on top. I'm a project manager, and I need to do some project. I need to develop some piece of software. So I will need people to do that. I will need people to help me. I will need an analyst, somebody who will talk to the customer, understand the requirements, and document that requirements for me. Some people call it requirements engineer, some people call it analyst, some people call it product owner. Let's call it analyst. I will need a programmer. I'll need somebody to implement those requirements, to write the actual, like Java, JavaScript, whatever code. Then I will need a reviewer, somebody who will review the code which is written by a programmer. Then I will need DevOps, somebody who will package this together and put it to production. Make sure that the code gets to production, gets deployed, and then, you know, customers get that code on their mobile phones or on their websites. And I will need a tester, Somebody who will take a look at that product and say, this product has problems, this product has bugs, I report those bugs, fix them. So this is not a complete list of people, of course, in a software project. There are more people there. Somebody has to do documentation, somebody has to design the architecture, maybe somebody has to maybe support customers. But let's say this is my team. Let's say these are the people who I found to build a product for me. They're all doing their jobs. Different sort of work, as you can see. Somebody writes code, somebody tests the product. Now I need to control them. Now I need to make sure that they actually do what I want them to do, that they work according to my expectations. I'm a project manager. I have a boss who gave me the budget, who gave me the time, who gave me some expectations, and who is actually funding all this, who is paying for all this, who is sponsoring the project. So I need to control these people, these 5 people working for me. I need to control the scope. I need to make sure that each of them does their work within the scope. I want the programmer to implement only the features the customer is paying for. I need to control it. I don't need to implement 5,000 features. I need to implement 17 features. This is scope control. I need to control somehow. I don't want the tester to test, Firefox when tester is testing my website. I don't want to know the bugs in Firefox. I want to know the bugs in my site. So I need to control the scope of testing. Then I need to control time. Cost. I need to control cost. I need to control how much they spend. I don't want the programmer to spend all my budget. I want to control that the programmer spends exactly the amount of money I have for the programmer. And I want to control the cost of testing as well. So I need to do cost control of programmer, of tester, of DevOps, of analyst, of all of them. I do cost control. And then I need time control. I need to make sure that each of them actually works within the time limits. So I don't want tester to test for 2 months. I want tests to happen within a week, for example. And I don't want the programmer to work for as long as they wish. I want them to stay within time borders. That's called time control. And I want to control quality. I want to control the quality of programming. I want to control the quality of DevOps. And I want to control the quality of testers. So quality control, quality assurance is something which happens on top of all these 5 people. Quality control or quality assurance happens for all of them 5. We don't only control, well, we need to control, now we're going to discuss how we control the quality, but you see the correlation between quality and cost and time and scope. So let's see how exactly quality can be controlled. And let's see the difference, first of all, between quality assurance and quality control. There are 2 different terms which people sometimes mix up and they don't really see the difference. I actually also don't see the big difference, but there are 2 different things, QA and QC, according to PMBOK. Who actually knows what PMBOK is? PMBOK. That's great. That's actually the book which I'm taking. Everything I'm saying today, almost everything, was taken from the PMBOK, from Project Management Body of Knowledge. This is how this book, this standard, this guideline defines quality control. So quality assurance is when we look at what our people are doing and thinking about what could be done better. So if we get to the previous diagram, to the previous picture, then the QA is like looking at programmers and thinking, why my programmers are producing so bad code? What's going on? Like, what's the real problem there? This is quality assurance. Like, I'm auditing. Maybe you don't see the text, but QA is about auditing. It's about looking around at programmers, at DevOps, at testers, and thinking, why my testers do not find all the bugs they need to find? They are testers of bad quality. Something is wrong with the quality of my testing. They are not finding enough bugs. Or they are finding minor bugs, and more important bugs are getting to our customers, and customers are not happy. So this is something is wrong with the quality of testing. So they are testing, they are finding bugs, but the quality of that is low. Or for example, DevOps. Something is wrong with my DevOps because every time we deploy something to production, the site goes down. So every DevOps procedure, every deployment procedure actually breaks the entire system. probably something wrong with my DevOps engineer. Maybe I need to find a new one, or maybe the existing one doesn't have enough resources to, I don't know, to buy a better server, a larger server. So the quality of my DevOps is low. This is quality assurance, quality audit, like I'm looking at this stuff and thinking. And then I decide, okay, how about I start paying attention to certain things specifically, and then I start quality control. Then I know what's going on, and then I decide, okay, in order to improve the quality, I need to, I don't know, fire that programmer and hire more testers. And then I start controlling, how is it going on? Like, do we have already more testers? No, not yet. Did we actually replace that programmer? No, not yet. So let's check how is it going. So that's probably, in my understanding, the difference between QA and QC. QA is about thinking, QC is about acting, like doing something to improve the quality. But again, what's important here to understand is that quality applies to all disciplines, to programming, to testing, to DevOps, to all of them. They all have certain qualities. So how can we measure that? Let's say I'm a project manager. Let's say I'm a quality person in the team. So there was a project manager, and now I'm the quality person. I'm hired by a project manager, and project manager says, we want customers are happy. We want our customers to be happy. This is quality for us. So make sure our quality is great. So what do? I have 5 people in the team. So I need to know what's going on with them. And let's start with requirements. So what metrics, what information about quality I can collect from my analysts, from my requirements, to understand what's going on, to understand what is the quality. For example, I can ask them to create a requirements matrix for me, and I'm look at this matrix and see which requirements are already implemented, which are in progress, and do they have this requirement matrix? Because many analysts, many requirements people, they don't have any metrics. They have just ideas in their minds, they have some document, but not really a matrix which shows the dependencies between requirements. Then I can pay attention to how the validation is going on. Like, do you actually check whether you are delivering the right product to the customers? Like, what was the last time you demonstrated something to the customer and got some feedback from the customer? What actually the customer is thinking about us? So I'm asking them, how high is your quality? I'm coming to the analyst and I'm asking them to show me something which they work with, and then I understand what is the quality. Or for example, the speed of approval, like how fast you approve the requirements, what's the process of that? If I don't see that, the quality is low, I need to address it somehow, I need to do quality control. Well, let's for example say coding. I go to my programmers, to my coders and say, like, how many lines of code you produce per day? Or how many hits of code, that's a metric which I introduced many years ago, and we use it in our projects a lot. Like how much code you touch every day. Show me numbers. That's how I am. I'm not a programmer, let's say. I'm a QA person. I'm a QA engineer, like you said, and I am coming to programmers and asking, show me your progress. How many of you QA engineers actually go to programmers and ask them to show the progress? You're not doing that. You're doing testing. What QA people are doing, they're going around the office and asking different people, different roles of what's going on. Like, give me metrics, give me information about your quality. And programmers may say, we have test coverage. Like, our code is covered by unit tests at this percentage and this and that. And that information will also tell me how high is the quality. If the coverage is higher, then it means that the quality is higher. Or I can take a look at static analysis. Do you analyze your code? How do you do that? I talk to programmers and they tell me. Or, for example, do you use some third-party tools for quality control or whatever? So the coding itself can be controlled by the quality. We can do the same for the code reviews. We can go to code reviewers and ask them how high is the quality of their work. And, for example, how long it takes to review one piece of code, or how fast, how soon you reject the code the other people are sending you. So I'm asking them what's the quality of their work. I can then do the same for the DevOps. I can ask them for how frequently you deploy the product, how fast is the deployment, like how soon it happens. And of course, I can check them, I can ask them what's the availability of the site on production. So if the availability is low, if the product goes down every time we deploy it, it means that the quality of DevOps is low. And finally, I can go as a QA expert, as a QA engineer, I can go to testers and ask them, okay, guys, you test, and now tell me how many bugs you find in each release, for example. And how many bugs you found in the previous release, and how many bugs you found in 2 releases ago. And then looking at these numbers, I can somehow judge what is the quality of your work. I'm the QA, you're the tester, I'm asking you what's the quality of your work, you give me metrics, and then I decide whether you're a good, whether the testing is good in my project or not. Or I can ask you like how many bugs per day you find, like this tester finds 10 bugs per day and this one finds 1 bug per week. Then maybe I can do the analysis of this and somehow decide which tester is better tester, which tester is not so good tester. And finally, well, there could be some rates. I don't know exactly how testers should be measured, how the quality of testing should be measured in your company, but it should be measured. So testing by itself is an activity the same as coding. The coder, the programmer writes code. The tester tests the code. They go in parallel, and they both attribute to quality. So the quality assurance stays on top. You, the tester, stays here. I'm the programmer, stay here. And we together contribute to quality. I produce bad code, you test well. The quality in the end is not going to be high. So I have to write good code, you have to test well. And then together, we do the quality, we assure quality together. So when the company says, to have high quality, we have QA people who are actually testing. It's not enough. It's only just one part of this diagram. The quality cannot be assured by just testing. To assure quality, you need to assure quality on all disciplines. That coding is of high quality, that DevOps of high quality, and testing is of high quality. I'm not sure whether in all of your teams actually testing is measured by itself, like how good is your testing, but it should. For example, let me give you like a practical example of how this procedure of addressing quality issues should look like. So let's say again I'm a project manager and I have this scope, cost, time, maybe people, risks, quality, like different knowledge areas they call, like different areas of control, of how I control my team. And then I have a team which is larger than before. So now we have more knowledge areas, we have more people in the team. Like you see, we have customers control, customer support, we have UI people, architecture people, documentation writing. So that's my team. And now we have the quality person on the right. So that quality person looks at what's going on, looks at the entire team, like what the team is doing, how testers are testing, how coders are coding. And then that person finds some metrics from the testers. Like these testers, my testers and my team are producing that amount of bugs. And they're finding bugs at the same area of product. Like the bugs are focused on this set of features. They are mostly here. That's the information I'm getting from my testers. And then this information comes to the project manager. I'm saying to the project manager, this area is broken, most probably something is going on with this area. It has to be addressed because we see, according to our metrics in the testing territory, that this area of code, of features, is probably more frequently. And the project manager says, okay, it's time to fire that coder, that programmer. So the corrective actions goes back to the coding area. The testers inform the project manager through the quality assurance layer, through the quality control, quality assurance, that they found something, which some trend, some dependency, some what do you call it? Some hidden knowledge which nobody knew before, that they suspect that somebody in the coding team most probably breaks more frequently something in this area because bugs are there all the time. So the information goes up to the higher level, to the project manager. That's called a change request, like make some changes with the team. and it goes down through the people control, and then probably we need to transfer that programmer from the Java team to another team because that person is not performing well as it should. So this is what's called quality assurance according to the standard called ISO 9011. Maybe you know about this standard. So if they come to you with this ISO auditors and they're gonna audit your company and say, are you actually compliant with the ISO requirements? Then they will ask you, do you have this process in place? Like, does it happen like this? So do quality assurance people come to the management time to time saying that we found the problem in this area in this discipline and that discipline, and that problem has to be fixed in this way. And then you apply your changes, and then you make the changes. And you have to document that. They will ask you for the journal of that, like, do you have a log of these events? Like, show us that you actually do that. And if you don't do that, if it's not happening like that, then you're not going to get the certificate. You're not going to be certified. So that's what's called quality assurance and quality control. As you can see, testers are staying next to programmers. Testers, programmers, reviewers, architects, they're all the same. It's the same, like they're on the same level. QA stays on top of them. And obviously you're not doing that. And think about your teams, think about your companies. Do you have that QA level or not? And of course, if you would be on that level, then you would understand all of these things I showed you before. You would understand all of these diagrams because this stuff is needed for a QA people. Testers don't need that. Programmers don't need that. But QA people who stay on top of us, they need these instruments because they analyze dependencies. They analyze metrics. They don't do any coding. They don't write any code. They hardly understand what it is. They don't do any testing. They don't know what Selenium is. They don't know what Jira is. They don't care about that. They just need metrics from you. So QA people can be QA people in any company, in software company, in medicine company, in logistics company, in any company. Because QA is QA no matter where. QA people pay attention to numbers, find dependencies, and address them through change requests. They don't write code, they don't test code, they don't know what code is. So QA is about management. Testing is about engineering. So we cannot say we're QA engineers. That just doesn't make any sense. There can't be any QA engineering. There could be QA people, QA management, like QA something. But if you're talking about engineering, then you're testing, you're a tester. You need to know Java, you need to know how computers work, you need to know how the code is being deployed, you need to know software engineering. But for doing QA, you don't need to know any of that. You need to know management. That's like two different layers, two different territories. So the question is, why do they call us QA instead of testers? So what's wrong with the industry? Like, why it's happening? And it is happening a lot. It's happening in many places. Like you demonstrated in the beginning. So many of you raised your hand saying that we are QA people. Even the name of the conference is QA Fest, meaning that many of us expect testers to be called QA. Sorry. I think it's wrong. I think it's actually damaging the industry in general. It's actually giving us the wrong message. So this is, first of all, is telling us that, first of all, actually the first problem is this. I give you this quote, it's quite like 15 years old, but it's still applicable. That testers, they have lack of status and lack of support in software teams. It's not me saying, it's that many people actually confirm that. The testers now are like second-class citizens. And you most probably can actually confirm that too. So programmers are like programmers and testers are like testers. So testers are just beginners, somebody who doesn't know anything about software development. They just first start as testers. And then maybe if you grow up, then you become a programmer. Am I close? Am Cynthia Coyne is close? Raise your hand if you feel it, if you feel that attitude in your teams. You don't, or some of you. Okay, so maybe over 15 years something changed. But, okay, how about this question? Do you as testers, as you feel, get the same compensation, like the same money as programmers in your team? Or you get less? Who gets less as you feel? Raise your hand. There you go. So most probably, the first question you just didn't answer, honestly maybe, but it's definitely happening. So testers are now like second-class citizens. And maybe because of that, I'm going back, maybe because of that, they give us the QA title to give us some respect, you know, to not give us money, but instead of money, give us the great title. Okay, we don't have money for you, but we have a title for you. You have a badge. It's a good business card. You're a QA person. You're not just a, you know, tester, but you're a QA, which is kind of silly. Well, in mind, well, it's not silly, but this is the way the industry works right now, and it's sad actually that it's happening, because that's the first reason. So the first reason is that they call us QA because they try to give us some respect. Instead of giving us more money, they just give us the title. The second reason is that I think that most managers just don't know what QA is in general. They just don't do quality assurance. They don't do quality control. They don't collect metrics from programmers. They don't collect metrics from DevOps. They don't put all these metrics together like I showed you before in this chart there. So they don't collect them all together and make the decision how actually to make to increase the quality in the team by doing something together in coding area, in testing area, in DevOps area. They don't know how to put these things together. All they know is that quality means more testers, or quality means better testing. Or maybe some of them say, you know what, yeah, it's good if we do code reviews as well. That will help maybe. But they don't do quality assurance, quality control, you know, in a complete way, like looking at all disciplines and putting these metrics together. They just don't know how to do it. And that's why they just make a mistake and they say, you guys are actually QA. And that's it. Ensure the quality, assure the quality. So that's sad. And maybe you know some other reasons. I'm not sure. So let me check for some of the questions and I'll go to my final part. Okay, so we have some people in the chat. There's some Jesus-driven development suggested. Well, yeah, let me check. Okay, so I'm getting to the final part, which is so how to become a better tester. I want to give you some practical recommendation. Now you understand, I hope you understand that you're not QA, you're testers. Leave the QA title aside. It's not applicable to you. You're not doing QA, you're doing testing. And now the question is how to be a better tester, how to make sure that you're doing the right testing and better testing and get more money. As we know, most of you are underpaid right now, so probably you want more. So how to do that? I think I can give you 4 recommendations, like 4 things which you should focus on. I'm actually not a good tester, to be honest with you. So if you put me in a testing role, I would fail most of all. I'm a programmer, but not a tester. In my opinion, the testing is a more difficult job than programming. To do the testing right, you need to have more skills. You need to have, well, first of all, you need to have different mindset, because programming is about building things and testing is about breaking things. So programmer is creating something every day, building new features, writing some new lines of code, improving something. The tester is every day giving negativity back to programmers, like this is broken, that is broken, let me break this one. Okay, I broke it, great. So the tester says great when something is broken. Programmer says great when something works. So you have to have a different mindset. The programmers are constructive people, testers are destructive people. And this is how it should be. Like testers should be looking to break things. They should be looking for problems, for defects, not for successes. So when the tester says everything works fine, it's a bad tester. The tester has always to be unsatisfied with the product. Like, no, I don't like it. It's not ready to be shipped. And the programmer's coming in and saying, no, it's good, let's ship it. And the tester says, no, it's broken, look at this, look at that. So in this conflict of testers and programmers, the good product will show up. So testers have to be negative all the time, which means different mindset. So that's the first thing you have to practice, to be negative about the code you look at. Don't say it's good, say it's bad, no matter what you see. I'm kidding. So, the first skill I would suggest you to develop is to code. So a good tester is, first of all, a good coder. A good tester is not the one who knows how to click all the buttons and just look at the product as a black box. A good tester actually looks into the code and understands the code and even can write the code, write integration tests, write automation tests, write Selenium tests. That's what a good tester is doing. If you're just a beginner, if you're just starting to be a tester, learn how to code. Actually, I believe that the best tester is somebody who was a programmer before and now became a tester. That's the perfect career shift in a company. You get the best programmer and you turn that programmer into the tester because that person knows how to break things better than anybody else because that person was a programmer. So learn how to code. Don't think that you will stay as a manual tester for your whole career. No, in that case, you will be underpaid. When you understand how to code, how to write code, you will become a better tester. Second point is review. Review the code people write. Participate in code reviews which programmers are doing. Raise your hand if in your company you have this code review policy like mandatory. It's like 50%, maybe a bit less. That's great. So if you have this in your company, if your programmers do code reviews, participate there. Ask them like, can I review that code as well? In most cases, they will not say no, because why not? The second pair of eyes is always welcome. So be part of those code reviews. That will help you to understand how those people make mistakes. And that will help you to break their things when they ship the product to you. When you look at the code, you know how they were making mistakes. You saw those mistakes, and you're going to break the code in front of you. You're going to look at your product as a glass box, not as a black box. You know the difference, right? Black box testing and glass box testing. Black box testing is when you look at the code, you look at the product. Let's say it's a mobile app. You just click the buttons, you try to use it. That's black box testing. But glass box testing is when you look at the app and then you look at the source code and you go through the source code and see, oh, most probably, because I see it here, when I click it in this, this and that way, then the product will break. This is glass box testing. And to do that, you need to understand the code. You need to know how the code is designed. So doing code reviews will help you a lot. The next point, I have 4. The next point is report. As somebody said, as many people say, the best tester is not the one who reports most bugs. It's the one who makes most bugs fixed. So your job is not to create many bugs and say here and there it's all broken, but actually to report them the way they will be fixed eventually. How to do that? You need to know how to report your bugs well. By reporting, I mean not going to programmers and talking to them and explaining them like, look, I click here, I click there, it doesn't work, but actually making reports, like formal reports. And that's art, actually. That's difficult. Not so many people know how to do that. Many people actually are used to informal communications, which is a problem. Formal communications is more important. So learn how to report bugs in a way that they get fixed, in a way that people understand you, programmers, people on the other side. They need to understand what you report. The higher the quality of your reports, the easier for them to fix your bugs, the better tester you are. So train that skill to report formally, not informally. Don't talk to them, report. The more you have informal communications in the office, the more you explain them what's broken, the worse favor you're doing to yourself. You will be underpaid for longer. Make it formal, report it. That way you train yourself, you improve your skills. And final point is that measure. This is how you help quality assurance, by measuring your progress. You have to know your numbers. You have to know that you're a good tester or a bad tester. And it's not just by asking your boss how good I am. This is not how you measure your progress. You measure by numbers. Calculate your numbers. How many of you actually know your productivity in bugs per day? Like 7 people in the room of like 1,000 people, I don't know, like hundreds of people here. 7, 10. all of you have to know how fast you can go. I mean, I am a programmer. I know my productivity. I know how many lines of code I can, well, how many features per day I can implement. I know my productivity. I know the number. You have to know your numbers as well. How many bugs you can find, how much time it takes for you to find one bug approximately, how many critical bugs you can find in this amount of time, how much time do you need to find performance bugs, and all of that. Like, you know your numbers, and then be ready to present your numbers to the management, to tell them that numbers, to give them that, to help them to do quality assurance. And I'm finishing. To do all that, I would recommend you, again, one practical advice, I will recommend you some books. Those are 5 books I strongly recommend to read if you want to be a good tester. Just make a photo, and this one. So these 5 books will help you to be a good tester. The book on the right will help you to be a good QA person. You need to know the difference. So read them both. Read the books about testing and read the book about quality assurance. In that case, you will understand the correlation between the 2 disciplines. And then you will understand that you are not QA, you're testers, which is great. Be a good tester is as important as be a good QA. And of course, the final book I would recommend, it's my book, which I wrote, published a few months ago, where I dedicated the entire chapter, not the chapter, but half of the chapter, explaining everything I explained today. You can get it on Amazon. I have 2 copies with me today. So you can get it on Amazon, and you can get it later if you email to this address. You will get it with the 50% discount if you were participating in this conference. I am done, and let me check the questions in the chat now. In the meantime, you can find the microphone and ask your questions if you have them. The question is in the chat, what is LOC and HOC? What is lines of code and hits of code? LOC is the metric from programmers, meaning lines of code. So how many lines of code the programmer creates. Many people say that this is a bad metric because it doesn't really demonstrate the progress of a programmer, because I could be a really bad programmer and write a lot of lines of code. Actually, good programmers, they write less lines of code because they can express their ideas in less lines of code. So this is, but still, it's a metric. It's a metric which will tell you something. If you have 10 programmers and you collect the number of lines each of them write, and then you see on the differences, then you will understand something. Like, I was in some team a few years ago and we had like 25 programmers and we never collected that metric, and we started to collect it. Like, we started to analyze how many lines of code actually some people write, and we were not surprised when we saw that the best programmers, who we thought were the best programmers according to our informal understanding, they were actually writing the most lines of code. So lines of code is a metric. It tells you something. Hits of code, also known as code churn. It's a term introduced by Microsoft many years ago. Hits of code introduced by myself like 5-7 years ago. It means that the amount of lines of code you touched when you were working with the code. So LOC, meaning new lines of code. Like, that was the piece of code of 10 lines. I created 40 more lines. We have 50 now. So my LOC, lines of code, is 40. So I created 40 new lines of code. But while I was working on these 50 together, I changed 200 lines. I changed this and that, and then I got back, and then I changed this. So I was working for a week. And I made many modifications with this line. So my total hits of code, so how many times I hit those lines, were 200. So 40 is my LOC and 200 is my hits of code. Hits of code is a more important metric because it actually is very well correlated with the productivity, with the effort a programmer puts into writing. So if there's 40 lines of code and 40 hits of code, that means that the programmer just wrote those 40 lines, committed them, and done. It's a different story when the hits of code is like 1,000 lines. So it was necessary to change those 40 lines many times, which meant more effort, more time to spend. So I would suggest to pay attention to both metrics. Another question is, we measure the test quality with the amount of bugs found per day. and maybe. I'm not saying this is the best approach to measure the productivity, the quality of testing by the amount of bugs found, but I don't know anything better than that. So if you know how to measure that, tell me. But somehow we need to find a way to measure the quality of testing. And I'm suggesting as one of the indicators, and one of the primary indicators, is actually the amount of bugs you find. I'm strong about that. A good tester finds more bugs. A bad tester finds less bugs. So when when I compare 10 testers, if I have a team of 10 testers, if you hire me as a manager of the team of testers, then the first day, I will ask my team, give me the numbers, how many bugs per day you find. That's going to be my first day at work. And then I look at this graph and I immediately understand who is bad, who is good. I don't want to talk to all these 10 testers. I don't want to discuss. First of all, I want to see numbers. And by that numbers, I will immediately understand who is working here and who is doing nothing. Then I will discuss. Okay, then I will sit together and say, like, why we're getting 1 bug per week from you and 10 per day from that person? Can you explain? Maybe I will find some explanation. Maybe there will be some stories like that bug I found was the most critical bug ever and nobody, maybe. But in most cases it will be like, you know, my grandma was sick and all that stuff. So that's the metric I'm suggesting. Yeah, actually the second comment is coming that, yeah, most people don't agree with that, but nothing is invented better than that. The microphone?
Okay, guys, maybe somebody has some questions. You can raise your hand and I will give you the microphone.
Another comment, yeah, while the microphone is getting there, another comment is QA is QA no matter where. That's a good summary, actually. Yes, QA, like I said, quality assurance is quality assurance no matter what the team is doing. Programming, you know, developing, you know, transition, logistics, medicine, whatever. Yeah, I'm ready.
Hello. So my question, let's get back to LOC and HOC. And what is your suggestion for which one we should to increase and which one we should decrease? It's a metric, so we need to decide what we are going to do in there. What is the goal? To increase or decrease?
Yeah,
Thank you.
Good question. Yeah, the question is again back to the metrics. So what the QA should be looking at? Like we're getting the numbers from programmers and lines of code, for example, is growing, hits of code is getting down or whatever, some correlation. I don't have an exact answer, but in general, probably I would try to decrease lines of code. The less lines of code we have, the better. That's, I think, obvious. So the shorter the code, the better for everybody. It's easier to maintain, it's easier to support, it's easier to understand, it's easier to modify. And the larger the hits of code, that means the more effort people are actually putting into writing those lines. So maybe that direction. So hits of code must go up, lines of code must go down. More questions?
Please raise your hand.
I'm checking the channel. Yeah, it's just a comment that what's the point of all this? Testing is not enough. We're not QAs. Most companies don't have this level. We're even damaging the industry. Yeah, that's yeah. I was not expecting to give you a positive, you know, talk. Well, actually, I tried to make it positive, saying in the end that we need to become better testers. But the reality, when you get back to your offices, when you get back to your bosses, they will keep saying that you're QA people. Let's do QA, and most of them will not understand what QA is. Like I said, do you need to argue with them? Do you need to show them the video of this talk? I think you should. Will it change something? I don't think it will. Because like I said, they want to pay less money, they don't understand what QA is, so it's a you know, problem of management most of all. Management, that's what's causing it. Lack of management knowledge, yeah.
Hello, I recently stepped to the role of quality practice lead in GfK Media Measurement Department, which includes 13 agile teams, and actually I'm doing what you're talking about here, quality assurance on every level. And I want to disagree with one thing you said, like about that escalation chain, that first of all you request the metrics. So what we are doing, that we are providing the tools and we actually automate the metrics for from every team. That's the first thing. So we're not asking, and we that's something that we don't steal the time from the teams. And another thing is that we don't do escalation. We go exactly to the root or to the cause of the problem and trying to fix that with, again, with automated tooling or with training for this coder which do the bad job or whatever. So I'm just curious, so why you think we should escalate? Why quality assurance from your point of view is just about management, not about engineering itself? Because I would say engineering here is also quite important.
Yeah, that's a good question. So you're just doing a great job. You just went way far from this diagram. So what you're doing is absolutely great. First of all, you're not going around the office asking for metrics. You made it automated. So you collect the metrics automatically. That's absolutely great. Of course, if testers can, provide the metrics automatically, for example, in one of my projects, we were just getting the metrics from Jira directly. So you just create some tools, or you just use the API of Jira, and then you can collect information about testing, not even talking to testers. So you just know what's going on. The next step is why the quality person responsible for the quality needs to go up to the higher level and bother the project manager about the changes, about the change request which needs to be done. Of course, again, a good suggestion, just give the permission, give the responsibility, give the authority to the QA people to make the changes directly. If the QA knows that in this block of code, the bugs are coming more and more often, then the QA just go directly to programmers and say, hey, we know that you're doing something bad, fix it, or to DevOps, without going to the higher level. But if somebody has to be fired, for example, then you cannot just do it directly. You need to go the full circle. So of course, you can cut corners, you can do shortcuts and just go directly to your colleagues, to your fellows who work next to you, and just apply those change requests. So that's what I'm saying. Your final point is that QA maybe probably sometimes could be about engineering as well, because quality needs to understand the root cause of the problem faster than in order to make decisions faster. That's a question, a very traditional question of do management needs to understand engineering and programming or not? I believe that's my personal opinion, is that the less manager knows about technical things, the better. So the ideal manager understands nothing about Java, testing, and whatever. That person just looks at numbers and applies management techniques, management instruments. The more manager knows about coding, the more manager understands what we technical engineers are doing, the worse it is for the project, because for many reasons. We can talk about that later, but there are many reasons for that. So I believe that management layer and the technical layer, they have to be as much separated as possible, ideally.
Thank you. We have one more question over here.
Hello. First of all, thank you for the presentation. It was really great based on this decomposition. So. Yeah, and my question is about that. What do you think? What is the best way to persuade each team member to think about quality? So to not go through this kind of long flow from testing to PM, then escalation, and then change requests to the developers, but to involve quality practices in each team members, in each part of teams, for developers, analysts, and testers, and so on. So yeah.
Yeah, it's a good question, actually. Great question. Let me rephrase it. So let's say we have the quality level here, and the quality level knows that we want customers to be happy, and we expect high quality from testers. And then how do we make sure that testers actually not only testing and finding bugs, but actually helping us to that higher level to address all the quality concerns? The first thing we need to do is we need to formalize that quality concerns. We shouldn't say just we need high quality. We should say exactly what we mean. What numbers are we looking for? So the management has to come to testers and look at first of all, look at the numbers. In most cases, there will be no numbers. So the management has to say, okay, give me numbers. So how are you doing in terms of numbers? And when I see the numbers, the management, if I'm the manager, I would say, I expect this and that numbers to grow 50% in the next month. And then I don't, maybe in most cases, I will not need to control them that hard because they're reasonable people. They will understand my expectations. They will know that that guy told us that 50% is what he expects in the next month. So I will not need to come to them every day and say, okay, how are you doing? How are you doing? I will just come back in a month and say, okay, you knew my expectations. How are you doing? And if the numbers will be at the same level, then most probably there is something really wrong with these people because they knew my expectations. They knew exactly what I was looking for. So to do it, to make sure people address those quality concerns by themselves, we need to tell them explicitly what we expect. And if the management doesn't tell you explicitly what they expect, either you're a programmer or a tester, and they just expect you to be great testers and great programmers, it's just lousy management. They just don't know what to expect. So in this case, you know what to do. Just give them nothing. And they will give themselves, they will give you salaries anyway. So if they're smart, if the management is smart, then they will give you numbers which they expect from you. And then you know what to do, and then you just address, follow the suggestions, do the numbers. That's it. We have many more questions in the chat. I will try to answer all of them later. We can just table this discussion for later.
Yes,
okay?
Thank you very much. I know that we have lots of questions, but unfortunately we are out of time.